Assalamualaikum warahmatullahi taala wabarakatuh and a very good morning. I wish to Encik Afin Akbar bin Mustam, my lecturer for MTES 3232 and my fellow friends. Today, I'm going to present to you about learning theories in learning mathematics. First of all, I would like to introduce myself first. My name is Ahmad Farhan bin Mohd. I'm from Maths 2 PSMP intake August 2024. Learning theories help educators understand the process of learning. Understanding and application of these theories is essential for effective instruction and successful curriculum development. This was quoted from Cynthia Schubert Irasoza, Academic Program Director for Inspired Teaching and Learning for the Sanford College of Education. So, learning theories helps teachers to understand their students' behavior, cognitive capabilities, and learning style. The discovery gathered all opinions in a theory to explain on students' essentials in order to create guidance for teachers to have an effective way of teaching to their students, and students can absorb the teaching with ease. So learning theories includes all of the aspects. Then it helps students in order to get the knowledge easily by doing all of these theories that have been gathered in a theory. As I said earlier, learning theories covered all of the aspects, the essentials for students in order to get knowledge with ease. There are five types of learning theories, and they are behaviorism, cognitivism, humanism, constructivism, and connectivism. In MTES 3232, we are going to learn only for two learning theories, and they are cognitivism and constructivism. These two types of learning theories are crucial because it helps students in order to understand their own learning styles, and as a teacher, it helps us in order to create a better and the best way of teaching, and it helps us to deliver the messages easily and make students understand it better. So in MTS 3232, we are discussing on six learning theories that can be classified into two types of them, which are cognitivism and constructivism. The first one is Piaget cognitive learning theory, which explains how children develop logical thinking and mental structure. The next one will be Gagner's information processing model of learning, which describes how the brain processes information in stages. Next, Ausubel's meaningful learning model, which emphasizes linking new knowledge to prior knowledge for better understanding. The next one will be Bruner's learning theory, encourage discovery learning and scaffolding, where students construct knowledge step by step. The next one will be Dini's stage of learning mathematics, which advocates structure, play, and exploration in mathematics learning. And last but not least, constructivism learning theory, which emphasizes learning by doing, active engagement, and real-world application. In this task, we are required to create an activity that helps students in order to understand a topic in mathematics. So I chose chapter 7 for 3D shapes in year 2 mathematics. In the previous class, before we proceed with this activity, teachers are required to teach this topic first in order for students to get a better understanding and recall from the past lessons. So on the day we are going to proceed with this activity, students are divided into four pupils per group, and each group will receive three different envelopes, and in each envelope it is filled with one layout of three different shapes. So the next one is each group should be start with only one envelope first. Then it depends on their creativity, but my suggestion is two of them should start with folding the layouts into a 3D shape, while the other two are going to find an object that satisfies the shape of the 3D object. And then once both of them finish the task, they have to bring both of the item to the teacher and name it in order to get approval. The last task will be they have to describe the shape that they have been created. So type of description that they have to describe are in terms of the basic shapes of the 3D object, the number of vertices, the number of sides, number of lateral faces, and curved faces. Once completed, each group will get a sticker and proceed with the next envelope. At the end of the class, do reflection with teacher. So from the activity that I have been discussed before, what are the learning theories involved here? So there are three learning theories that involved, which are Bruner's learning theory, Ausubel's meaningful learning model, and constructivism learning theory. And I am very sure from this combination of three learning theories, will help us to understand the knowledge and understand the topic better. How does Bruner's learning theory apply here? The first one is where the students have to find an object that satisfies the shape. Students actively creating knowledge explore different real-life objects around them to find the same shape. First one is teachers have to give the basic knowledge to the students in the previous class. So during the class that we are proceeding with this activity, they just only was given the 3D shapes in order for them to find the real life object in the class. And by applying the knowledge and relate it with the real life object, it helps students to get a meaningful learning where students can find the most similar shapes of the 3D object with the real life object. The next one is where the students were given three different 3D shapes layout. When teacher provides students with three different 3D shapes layout, it is actually one kind of representation and active as when knowledge generated through action. And in Bruner's learning theory, they have highlighted three different types of representation, and one of them is inactive. And for inactive representation, it is an physical um, representation or physical stimulus for the students to understand the learning. So 3D shapes layout that was given in 3D, they will explore it physically and will fold it until it get the most similar shape, and after they get the shape, they are going to find the real life thing. The next one is Ausubel's meaningful learning model. Let us have a look on the TSKP for Mathematics Year 1 and Year 2. For Year 1, 7.1.1, they are required to name cuboid, cube, cone, square base pyramid, cylinder, and sphere. The next one is 7.1.2, describe surfaces, sides, and vertices for 3D shapes. In Mathematics Year 2, they are required to determine 3D shapes from the characteristic description. Then 7.1.2, determine the basic shape for each 3D shapes, and 7.1.3, they have to determine the nets for different 3D shapes. And all of these learning standards have been discussed and applied in our activity. Let's have a look. So let's have a look where this learning standards for year 1 mathematics applied here. So in this activity, for mathematics year 1, 7.1.1 is applied where the students have to name the object, the 3D shape, sorry, during the activity. Once they created the 3D object, 3D shapes, and they find the object, they will bring both of the item to the teacher and they have to name it. And this is where it applies the 7.1.1. And for 7.1.2, for mathematics year 1, it is described during the description of the shape. When they bring both of the item and they get approved, once they get the correct name of the 3D object, they will have to describe the shape. And during the description of the shape, they are going to mention about the number of vertices, number of sides, number of lateral faces, and the curved faces. So this time around, they are going to apply this 7.1.2 in the activity. So let's have a look at the SKP of learning standards for mathematics year 2. For 7.1.3, actually they are applying the knowledge of layouts of 3D shapes in this activity, because in year 2 actually they are learning about how does 3D shapes were the layout. So, in this topic, they are actually applying the knowledge into a physical activity. So the next one is mathematics year 2, 7.1.1, which they have to name the 3D object from the object that were created. And the next one will be mathematics year 2, 7.1.2. They have to describe the shape, and the specific part of the description will be the basic shapes of the 3D object, of the 3D shapes. Then I found that two relation between topics in year 1 and year 2. Let's have a look. 7.1.1 in year 1, naming cube, cone, and square base pyramid, cylinder and sphere. And in year 2, 7.1.1, determine 3D shapes from the characteristic description. These two topics are somehow related because it somehow requires students to name the 3D shapes from the description given. And then the next relation will be is 7.1.2 in year 1, describing surfaces, sides, and vertices for 3D shapes. And in year 2, 7.1.2, they have to describe the 3D object by using the basic shapes of the 3D object. And then this is somehow they are required to describe the 3D object by few characteristics that were given. So this is somehow shows that prior learning plays a vital role in order to understand a new topic, because in year 1 they have the foundation of these 3D objects, and they are going to use these topics, this knowledge, this prior knowledge in year 2 while learning the new one. The last theory will be constructivism theory. There are four stages of constructivism theory, which are the first one will be active constructivism. Students can actively create knowledge through interaction. This do not only involve physical interaction, this includes verbal interaction for communication, sharing knowledge between peers, and etc. And during the active constructivism, while they are interacting with the others, actually they are not just learning, they are just applying the knowledge, the skills in order to get the goal. And then the next one will be the schema theory. Connects what they have learned in the past with what they are going to learn today. This connection will produce a stronger impact on the new knowledge generated. As what we have discussed in Osabel's learning theory, they have the foundation of the 3D objects during the year 1 standard. But when they are going to learn something new in year 2, they are using the foundation in year 1 in order to get a better understanding during the year 2. So this shows that schema theory is very important for them to understand a new knowledge from a prior knowledge. So the next one will be social interaction. Through social interaction, this interaction unfolding the nets together and finding similar objects will spark solid collaboration and communication skills, despite they are actually sharing knowledge and opinions in solving a problem. So in this part where the students actually focusing on the social interaction, and it is not only focusing on the learning part. They are actually building the skills of communication and collaboration. And it happens where the students actually, some of them have to create and fold the 3D object until it get the shape of the 3D object. But if they fail, some of them will be help them in order to get it correctly. And same goes to those who go to find the real life object. If they found the wrong object, they will go and find it together and help them to understand it better. Maybe they can describe the 3D object and 3D shapes for a better understanding for their peers. And then the next one will be the reflective thinking. At the end of the session, they will realize that they are actually exploring real life objects and classifying them into various 3D objects indirectly. This helps them to create a meaningful learning by having relation with their daily life. As I said earlier, when they are exploring their class, surrounding their class, for the object that satisfies the 3D shapes, actually they are not only playing a game, they are actually relate their knowledge to the to something that have around them, which is real life objects. So this is somehow will create a meaningful learning for them, so they can apply this kind of knowledge outside of the class. After we have been discussing how learning theories apply in this activity, so let's have a look at the implications of learning theories and constructivism in learning mathematics. The first one is encourage discovery learning. In Bruner's learning theory, students are given space to explore topics they are going to learn. In exploring the topic, they will learn the topic indirectly. Yes, it is two in one way in order to get them excited and also fun but in the same time they are going to learn something new. And how does this work? Students will take part in exploring different objects that satisfies the 3D objects. Instead of learning through a textbook, they can relate things in the surrounding, especially in classroom. When they explore themselves, they will keep them to continue generating new ideas and relate topics and real life situation, because I am very sure that students are very boring during the class where they have to listen to the teacher and just look at the textbook. They don't have any physical interaction, physical activity that makes all of their muscles working while they are gaining the idea. So by applying this kind of activity, physical activity, they are actually not only playing a game, but they are playing physical activity that help them to generate ideas and gain new knowledge and understand the knowledge better by using the physical activity and creating the 3D objects by folding the nets. The next one is it helps students in order to link new to prior knowledge in Ausubel's meaningful learning model. Math concepts are easier to grasp when connected to what students already know. With new concepts introduced, prior knowledge helps to create a strong foundation for it. How does this work? Let's say in year one, they are not given opportunity to learn about 3D geometrical shapes, then they are not able to name the shape and describe the characteristic and vice versa. And this kind of activity will be filled in order to proceed it during the class for in year two, because they don't have any basics. Because in year one, they are actually exposed with the shape visually and the name of the shape. But in year two, they are not going to repeat the same thing. They are going to learn something new, but somehow related to what have they learned in past. And as what you can see on the screen, I am mentioning what kind of topics they are learned in for year one and year two. So in year one, they are actually naming cuboid, cube, and other 3D objects, 3D shapes. And in year two, actually they are determining the 3D shapes based on the characteristic they have learned in year one. Okay, there is somehow Ausubel's meaningful learning model trying to say. So the next implications of learning theories and constructivism in learning mathematics is learning is an active process which is mentioned in constructivism learning theory. Students build their own understanding by solving problems and making sense of concepts. Interaction between peers will contribute a lot in learning mathematics. They are not going to learn only by themselves, but they are contributing something into their class and actively participated during the learning process. They are not going to just learn about the topic, but they are learning on how to build their skill, to build communication skills and collaboration skills. So while doing the activity actively in the class, actually they are going to have interaction with their friends, and during that interaction they are building that kind of skills. And while they are building that kind of skills, actually they can have sharing knowledge sharing between peers. And how does this work? Teachers assistants as a facilitator and students conduct the lesson. They are the one need to explore, ask for any questions, making relationships between knowledges, having collaboration with friends, and many more. Just now we are focusing on the implication of learning theories and constructivism towards learning mathematics. But this time we are going to focus on the individual differences. The first one is caters to different learning paces, constructivism learning theory. The students progress through inactive, iconic, and symbolic stages at their own speed. Some students might still need physical object to get better understanding on some topics rather than directly learn on calculations. And yes, this is somehow true because each of them are unique because they have their own learning paces. So in order as a teacher, in order to get a better learning environment, teachers have to understand their students' learning paces and try to make it more easy for them to learn things. And how does this work? Everyone has their own uniqueness. With the help of physical items inactive such as 3D solid objects, students can get better visualization on how does this shape looks like. Same goes to describing the shape. They can have physical touch and physically count on the number of vertices and sides of the shape. Yes, by just looking at the textbook and look at the visual of the 3D object, for example, cube, they are just learning theories. Yeah, because they are just look at the 3D visual thing on in the textbook and just knowing that there are six vertices, six sides of the object, for example. So by learning it through physical touch, physical activity, and physical things, which is inactive representation, so they can exploit themselves. They can calculate the number of vertices and also the number of sides that they are going to touch it. The next one will be support students with different prior knowledge levels or Serb's meaningful learning model. Different levels of prior knowledge could impact the understanding of the new topic. Those with lower levels could need more guidance in order to understand topics that might depending on their prior knowledge. And it is different for each student because some of them can adapt the new knowledge easier because they have the solid foundation, but some of them might not get the new topic, the understanding for the new topic easier as what the other do. Okay, so how does this work? Teacher plays a huge role to determine which students seem struggle to learn new topics. Teachers can have a recall session on a previous topic learned. Yes, if you seem that students seems struggles to learn new topics, they might shows that the students might shows that they are struggling and they have lower levels of understanding for the past topics. So the recall session on the previous topic learned help students in order to understand it better or get the visual or the early visual of the topic they are going to learn. Last but not least, the implication of learning theories and constructivism towards individual differences is encourage collaborative and self-paced learning. It is mentioned in constructivism learning theory. Stronger students can help others while weaker students build understanding through exploration. How does this work? When students know they are weak in certain topic, they can have a slower paced learning processes and do more exploration in this topic. Those who can adapt the topic easily, they can utilize their ability to teach others because peer-to-peer teaching, as this is one of the effective way in learning. So this is how they can collaborate, not just while doing the game, but in outside of the game, outside of the activity, because they know that they are weaker or maybe even stronger than others. So they can utilize their ability, their disadvantages and advantages in order to help each other, and they can even make their understanding better. After all discussions, we can have some reflection. So, mathematics learning should be active and meaningful. Learning is most effective when students engage actively with concepts rather than just memorizing formulas. Goodness discovery learning also builds meaningful learning, and constructivism all emphasize understanding over rule learning. So this is where learning theories happened and it makes impact towards students, and they can do more understanding and get a better and a meaningful learning towards it. Next, different students learn in different ways. That's the fact. Bruner's theory supports different learning paces through inactive, iconic, and symbolic stages. Also, Bell's model ensures that students can connect new knowledge with prior understanding, and constructivism allows for collaboration, problem solving, and real world application, making math accessible to all learners. This is where all the learning theories make impact because each learning theories provide and give something different to students and also teachers so they can adapt those techniques, those ways in order to adapt with their own learning pace. This is the most important part. Teachers plays a key role in designing effective learning experiences. Teachers should use hands-on activities, visual aids, and real-life examples to make learning engaging. Differentiation is important. Some students may need more visual support, while others may learn best through hands-on experiences. Encouraging group work and discussion helps students develop problem solving and critical thinking skills. So, teachers' role are important as it is because they should know what are their students' learning pace and what can help their students in order to understand better on topics they are teaching. So, teachers, please pay attention to your students because you are the one that make the learning more effective if you do your own research towards your students. Thank you so much for watching. I hope after this discussion, it will give us something to bring back to your school. So, remember, teachers, please pay attention to your students and make your class more interesting and engaging at the same time. Thank you.